Hello, welcome to this video. It's PS the tutor. In this video, I want to introduce you to the concept of Ohm's law. That is, the relationship between voltage, current, and resistance. Voltage, all right? This can be the EMF, which is the electromotive force. It can also sometimes mean potential difference, but clearly there's a difference between EMF and potential difference. While current is just concerned with the flow of charge, and resistance is just concerned with the ability to resist what? The flow of charge. That is resistance, the ability to resist the flow of charge. Now, how come these three are used together? Now, we use them together in a concept called Ohm's law, which states that the voltage is equal to the product of current and resistance. So if I give you a situation like this, okay, let's say we have a source, okay, then we say we have a resistor there. Let me do this. We have a resistor here, okay, then we have 12 volts and a resistor is 4 ohms. How do we find current? All right, so from here you'd say that since voltage is current times resistance, making current the subject of the formula gets us voltage over resistance, which will give us 12 volts. We divide by 4 ohms, which just give us 3 amperes. Current is measured in amperes. Now, it's not always that something as simple as this can come. Let's look at a scenario where we get a circuit like this. Okay. We have a situation like this. Instead of giving you one resistor, I give you 2 resistors. And in this closed circuit, this one is 2 ohms and this one is 3 ohms. And here I put 10 volts. How do we find current? Okay, how do we find current? Now, take note that these 2 resistors, the way they are like this, they are in series. What do we need to know about series connection? Resistors that are in series, one, the same current flows through them. So the same current, so let me just say the same current flows through them. But those resistors, they have different voltage flowing through them. They have different voltage flowing through them. So we are saying the current flowing through here and here is the same. That is the total current coming out from the circuit. You know that current is voltage over resistance. But since these are in series, you just add them up. Since they're in series, you just add them up. So our voltage is 10 volts. Our resistance, since they're in series, you just add them. 2 plus 3, that gives you 5 ohms. And this will give you 2 amperes. This means in this resistor, there is 2 ampere flowing, and in this resistor, there is 2 ampere flowing. Well, in a situation where I give you this, let's say I give you 2 resistors. In this case, they are in parallel and not connected in series. How do we handle such a situation? Okay, so let's say we have them connected like this. Okay, so they're forming a junction there. Let's call this one 10 volts, the same way it was. And let's call this one 2 ohms and this one 3 ohms. So how do we find the total current? So these are now in series. In parallel, not series. These are now in parallel. What do we need to know about parallel? Well, same voltage for each resistor. Each resistor has got the same voltage. Now here we are dealing with different current for each resistor. And how do we find the total resistance? Now, you don't just sum them up just like that, but you sum them as the reciprocal of each other. So we are saying 1 over total resistance is just equal to 1 over resistor 1 plus 1 over resistance 2 plus so on plus Rn, where Rn, it just means N can be any number of resistors that are there. Resistors, sorry. So in this case, we find the total resistance. We get 1 over Rt is equal to 1 over 2 plus 1 over 3. Common denominator 6, we get 3 plus 2. This gives us 5 over 6. Now remember that here there is 1 over R, so 1 over Rt is 5 over 6. But we need Rt, not 1 over Rt, so we reciprocate. 6 goes on top, 5 comes down. So if you divide 6 by 5, we are getting 1.2. So the total resistance is just 1.2 ohms. How do we find current now? Current is voltage over resistance. This is total, by the way. The voltage is 10 volts over 1.2. So we're saying 10 we divide by 1.2, and I'm getting about 8.33 amperes. Now, we used the same resistors here, and we found that the current here is 2 amperes, but the current here is 8. Why is it different? Well, in parallel, the resistance will always be smaller than in series. That causes a decrease in the current. But again, come here. Since we said same voltage, so in this one we have got 10 volts flowing, in this one we've got 10 volts flowing, but different current is flowing there. If you need to know more about this, you can start my online classes. You can also inbox me so that you can consult me more about how I conduct my online classes. See you.